In this video, I prepared for you a Prisma crash course where you will learn everything that you need to start working with Prisma on a real example. And the first question is, what is Prisma at all? As you can see on the official website, it is an ORM for Node.js and TypeScript. So what we're getting there is a data model, migrations, type safety of TypeScript, and an awesome autocompletion. And the main question before we start with Prisma, what databases we can work with it. And as you can see in documentation, we can work either with Postgres, MySQL, MariaDB, SQLite, MongoDB, CockroachDB, and so on. Which actually means the amount is quite big, but mostly it is being focused on relational databases. Yes, it can work with MongoDB, but I can't really say that I'm satisfied with the results or with code, because mostly it is focused on relational databases, and this is exactly where Prisma shines. And here I created a small project for us. First of all, we can see tsconfig with the configuration of Node.js, because we will write TypeScript inside Node. Also, I have a fully empty package.json, and inside source I have an empty index.ts. And for our application, we want to use Express together with TypeScript and Prisma, which actually means here we want to install Express as our dependency. And additionally to that, we want to reload our application on every single change. This is why we will install NodeDaemon, which does exactly that. And in order for NodeDaemon to work with TypeScript, we must install tsnode, and also we can install types for Express. And this is all our dev dependencies, we don't need them for production. Let's check if it's working. We must jump inside our source index.ts and let's write here console log app. Now I want to jump inside my package.json, and here inside scripts we can call our script, which we can name dev, and here we can write NodeDaemon source index.ts, which actually means we will start our application with NodeDaemon, so it will support reloading. Now I can write here npm run dev, and as you can see in the console, we're getting app, which actually means it successfully transpiled our TypeScript to JavaScript, and we see the output in the console. Our next step will be to generate an initial files for Prisma, and we will do that with the help of npx Prisma. And after this we will execute a lot of commands. The main idea is that npx Prisma is a command line tool to execute Prisma commands without installing any additional package inside our project, because essentially we don't need Prisma inside our project. We will need Prisma client later to execute queries, but not to set up it. This is why here I am writing npx Prisma init -- data source provider SQLite. So what it does, it will generate for us a Prisma config, and it will set inside that we want to use here SQLite. You can provide here, for example, Postgres or MySQL, whatever you prefer. I'm hitting here enter, and we're getting lots of information. First of all, your Prisma schema was created at Prisma schema Prisma. And it is important to remember that in your project by default, all files of Prisma will be living inside Prisma folder, and the most important file there is the schema Prisma. After this, we're getting the warning that we already have a .gitignore file, and we should not forget to add .env file inside gitignore. Why is that? Because it created for us .env file and it put inside the database URL. Let's have a look. I will jump inside files, and here we have two things. First of all, inside Prisma, we're getting schema Prisma file, and this is the initial file. Here we have a generator, we don't need to change that, and we're getting a data source. This is exactly what we provided as an attribute for our command. So here is our provider SQLite. You can write here, for example, Postgres if you need to, but as you can see here, we are getting a URL, and it is coming from env database URL. So it is not written directly here, it is being configured through environment variables. This is why inside our project we are getting .env file, and just from the start I want to jump to my gitignore where I have node modules, and as you can see here I already ignored .env file. This is extremely important because we want to never commit this .env file to GitHub or GitLab, because this is not safe. It will contain our URL for database. Let's have a look now in our .env file. There is just a single line here, database URL, file devdb. And if you are using Postgres or MongoDB, you will write here the full command how to connect to your database, which will contain your host, your port, your login, and your username. With SQLite, we are getting this devdb directly generated inside Prisma folder. The next thing that I want to do is to write some schema inside Prisma. This is why let's open Prisma schema Prisma, and in this file we are generating all our models, so all our entities with which we want to work. Let's say we have a project with users, posts, popular tags. You will create all of them here, and then Prisma will generate for you tables and manage all these entities. So this is the only source of truth when we are talking about entities and Prisma. And in order to create an entity, we can write here a word model and then the name. For example, let's say that we are creating a user. Now inside we can write that we have an ID and this is our field, and we are writing its type and it is int. After this we can put add ID to tell that this is an ID property, and here add default because we want to use here auto increment. So here will be auto increment with round brackets. After this we will have an email, and our email is a string, and we must make sure that our email is unique. And the last one here will be username, it is just a string. So what do we have here? When we are defining our models for our entities, we are using model keyword and then the name of the entity, and then we are defining all its fields. So first of all, it is a key and then the type of this key. This is exactly how it will be stored in the database. Also, for example, for email, it is important for us that the value is unique. This is why here we are writing add unique. For ID, first of all, we say that this is our unique identifier and it must be auto-incremented and provided by default, which actually means we don't need to provide an ID to create our user. And with that, we successfully created our first model user. The next step that we want to do is generate a migration. So what is migration? This is an extremely important and safe thing which allows you to create snapshots of your table. For example, our first snapshot of our table, the table is empty. Our next snapshot that we want to create is how our database was changed when we created this table user. And in order to do that, we can jump inside console and write npx prisma migrate. Here will be dev, because we're talking about development database, and here -- name, and we can provide any name, for example, edit user. I'm sorry for interruption, but I just want to let you know that I have lots of advanced courses on different web technologies where we create real applications and prepare for the interviews. You can find the link in the description box below. Now let's jump back into the video. And the name here defines exactly what we're doing inside with our table. I'm hitting here enter, and what it does, it generates for us a migration. And here again we got lots of output, which really helps in debugging and understanding what it does. First of all, it loaded our DB URL from .env, then it finds this Prisma schema Prisma, and our data source is DB, and it is living in devdb. Now after this, it creates our database, devdb, and it applied the migration with this name that it creates. And as you can see here, first of all, here we're getting a timestamp when this migration was created, and here we're getting a message that it was created. And now the green message is your database is now in sync with your schema. This is exactly what we want. We always want our database to be in sync with our schema. Let's have a look what we're getting. Inside our Prisma, we're getting lots of stuff. We're getting here devdb, this is exactly our database, and we're getting migrations folder. And inside this folder, we're getting the folder with edit user. And inside we have just a single file, migration SQL, which is exactly the SQL code which will change our database. So we had an empty database, and it executes this migration, so it runs this code in order to create a user table with these fields. What we can do now, we can open our database and check what we have inside. And in order to do that, I am using the tool which is called DB Browser for SQLite. You have this tool on different operational systems. And here what we are clicking, open database, and then you can simply select that file inside our project. And this is how it looks like for me. As you can see here, I have a database structure tab activated, and this is what I have. On the left you can see tables, and we're getting here 3 tables. First of all, user. This is exactly what we defined, but additionally we're also getting Prisma migrations and SQLite sequences. Let's have a look on the user. We can open it, and here we can see that it has 3 fields. ID is integer, email is text, and username is also text. And here when we're clicking on Browse Data tab, we see that our table is fully empty, but we have these 3 fields: ID, email, and name. And the last thing that we want to do with Prisma, before we start to bind it to our Express project, is to generate some starting data. This is why inside Prisma folder we can create a new file and call it seed.ts. And in order to generate some data, we need an additional package which is called Prisma Client. And this is the first package which is related to Prisma that we're installing in this project. This is why here I'm writing npm install Prisma Client. And now here on the top we can import our Prisma Client from Prisma Client. Now here let's create Prisma by calling new Prisma Client. And after this I want to create an asynchronous function run which will generate all our data. So what I want to do inside, I want to create a new user by calling await prisma.user.create. And as you can see here, we're getting an amazing autocomplete for Prisma user. So it's understood that inside our project we have a user, and now it builds correct autocomplete for the whole project. And this is extremely important to understand. Prisma doesn't only give us some methods for ORM, it really takes from our schema Prisma this model user, and it creates all these additional entities and all this autocomplete exactly for our entities inside TypeScript, and we can use them. This is why here inside our seed we can write user create, and we're providing inside an object with data where we must provide a correct data inside. And as you can see here directly, we're getting an amazing autocomplete of Prisma. We're getting that our object is missing the following properties, and it must be email and username, which actually means we're always on the safe side with Prisma. Here I will write that we have an email, for example, foo@gmail.com, and also a username, let's say foo. So we successfully generated our user. Now I want just to console log it in the console. And after this we want to run this function. But the main point is we want to connect to Prisma first in order to run it. This is why here we can call this run.catch. And if we are getting an error of connecting to Prisma, we want to console log this error, and we want to call process exit. And after this we also need finally, and this is an asynchronous function where we want to disconnect from the Prisma. This is why here await prisma.disconnect. So what this code does, it tries to run our logic, and our logic is to use Prisma to create a user. If it doesn't work and it catches the error, it shows the console log, for example, unable to connect to Prisma, and we're coming out. And in any case, at the end, it disconnects from the Prisma. Doesn't matter if we successfully created our data or we got an error. And now in order to generate seed data in the Prisma, we can use a command npx prisma db seed. As you can see here, after executing this command, we're getting an error. To configure seeding in your project, you need to add a Prisma seed property inside your package.json. And here we can see even this code. So essentially we just need to copy this Prisma part and jump inside our package.json and put it here on the bottom after our dev dependencies. So here we have a Prisma object with seed field, and here ts node prisma seed ts. This is exactly the path for our seed file. Let's call it again. And as you can see here in the console, our user was created, and we're getting that the seed command was executed. Now we can open our database again and click Browse Data, and as you can see here, I'm getting the first user with ID 1, email foo@gmail.com, and username foo, which actually means we successfully generated our first user in the database by using seed data. And before we jump in using Prisma together with Express, I want to show you super important command, and this is npx prisma generate. So what this command does, as you can see here, it loads the schema from Prisma schema, and then it generates Prisma client. And the most important part is where it generates it. It is inside Node modules Prisma client. And in order to understand what is Prisma client, we must think what we already got. As you can see here inside our Prisma seed file, we used this Prisma user create. And it looked like magic because for some reason Prisma knows exactly what entities it must create, and it creates TypeScript data types to cover all this code. And what it essentially does, when we are calling the command Prisma generate, it generates for us this Prisma client, which actually means it reads our schema and prepares all typing files. So now we can jump inside our project. We have node modules, and here is a net Prisma folder. And inside we have .prisma folder, and inside it we have a client, and here we have our index.dts, for example. And here you can see that we are getting exactly the model user with all its autocompletes, which are built exactly for us. So there is no magic really. Prisma simply takes the schema and generates a bunch of TypeScript. But the most common problem of people by using Prisma, they simply forget to run this generate command, and then their schema file is out of sync with their Prisma client, and then they are getting some magic errors regarding fields that they wrote inside Prisma schema. So every single time when you update your Prisma schema, you want to run npx prisma generate. This is super important. With that being said, let's implement our Express project. So what we want to create, we want to connect to our database, then get a list of our users, create a user, delete a user, update a user, and get a single user. So first of all, what we need here is to import our Express from Express package that we already installed. Additionally, we want to import here Prisma client exactly like we did inside our seed file. We will use it in the same way. Now here we need to create our app, which is an Express app, and we want to create Prisma by calling new Prisma client. After this, we want to make sure that we can parse body correctly. This is why here app use, and we're providing inside our express.json and also app use express.url encoded, where inside we're providing extended true. Now we're on the safe side and we can parse body of our request. After this, what we can do, we can listen our application on port 3000, and here I want to write a callback that our application is successfully started. Let's say API started. And the first thing that I want to implement is getting a list of all our users. This is why here let's write app-get, and we want to get a list of users on the route /users, and here we're getting access for our request and response. And what we want to do, we want to call our Prisma here to get our result. This is why here we can wait for the response, because every single request to the database will be asynchronous, and we can call here prisma.user. As you can see, again, amazing autocomplete and millions of different methods. And we want to call here find many to find all our records. After this, we can simply respond with our result. And obviously, if we're using here await, we must make our function asynchronous. So as you can see, we wrote super small amount of code, and it is really readable. Let's test our API. We have here a URL localhost 3000/users, and this is a GET request, and I'm hitting here send. As you can see, back we're getting an array with all our users, and here we're getting just a single user, which we created with seed data. So it is just a normal object with ID, username and email, and we successfully created our GET request. Now let's implement creating of the user. So it will be a post request, again on /users, and here we're getting our request and response. And here we want to get a result as a created user, and in order to create a user, we're calling prisma.user.create exactly like we did inside our seed file. And inside we're providing data which we're getting from request.body. And after this we can simply respond with this result. Let's try this out. This is the post request, and we must provide a body. And inside I'm providing an email, buzz, and a username. I'm hitting here send, and we successfully created our record in the database with ID 2. But here is a small problem. If I'm clicking again send, as you can see, our request failed, and inside our console we can get that invalid Prisma user create. Why it is invalid? Because here we have a unique constraint failed on the field email. As our email is unique, we can't really create a user with the same email. And we must handle it correctly. This is why let's wrap our code with try and catch an error. And what we want to write here is just response with JSON. For example, error, email or username are not unique. Let's try it again. I'm hitting send and we're getting an error. Email or username are not unique and we're on the safe side. So this is how we can catch constraints from Prisma. Now we must implement getting a single user, which is also extremely simple. So here we're creating a URL/users and the dynamic ID. And we have here our callback with request and response. And what we want to get back is a result by calling await on prisma.user.findUnique because we are sure that our ID is unique. And inside we can provide a where predicate with some constraints. In our case, we are looking for a record by ID, and here we can write request.params.id. But here directly we are getting an error that type string is not assignable to type number, which actually means we are getting our parameter from URL and it is string, and we must convert it to number, for example, with number function. So this will find for us either a null or an existing user, and we can respond here with our result. Let's try this out. I will write here /users/2 and it must be a get request, and let's hit send. As you can see here, our method is working. After this, let's implement updating of our user. So it will be a put request on /users, and here is a dynamic ID, and here is our callback with request and response. And essentially, I want to copy paste here the code from the get because it will be super similar. So here we want to call not find unique but update, but inside we're providing a where, because essentially we want to find the user by ID that we will update, and additionally we are providing inside data from request body that we want to override. And after this we can respond with our result. So here we are updating our user, where we are finding it by this ID, and we are updating this body. Let's try to update our user too. Here we are making a put request and it was bars. I want to change it to bar. And let's update also our username. I'm hitting here send and we successfully updated our user with Prisma. And last but not least is deletion of our user. I will copy this put request and just update it. So it will be a delete on /user/id, and inside we want to find the user and call not update but delete, and we're providing inside where by this ID, and we don't need to provide any data, which essentially means we're finding a user by this predicate and we remove it. Let's test this out. Here is /users/2 and this is a delete request. I'm hitting here enter and we're getting here a user that we removed. Now let's check if it was really removed. Here we can make a get request on /users. I'm hitting here send and we got just a single user because our next user was removed. So Prisma simplifies our working with database a lot, but if you are not proficient with using ORM, it makes a lot of sense to use natively MongoDB together with TypeScript, which I cover in this video.